I'm live. Yep, you're live. Okay. Good evening, Year 11. This is Mr. Russ along with Mr. Sanders. Say hello, Mr. Sanders.
Hello, Mr. Sanders.
Hysterical. Through some higher questions. I'm going to start on some crossover questions, and I'll do a few. If Mr. Stark is around, he will jump in and do a few turns. Thank you for your feedback from last time. We've quickly amended the content we were going to deliver, and we are now using mini whiteboards and mini whiteboard pens. Hopefully you can see it a lot clearer. Okay, so to start off with, some questions that hopefully might ease you into that exam tomorrow morning. Miss Milner did cover fractions, but you've seen them twice. So hopefully whilst being talking, you've been thinking how you may answer this first one. So we have 3 and 5/9, subtract 1 and easy if you can deal with the fractions if we start with getting them to be mixed numbers. So 3 and 5/9. Well, 3 is made up from 27 ninths. 3 nines are 27, and then adding the extra 5 will give me 32 over 9. And 1 1/2, well, 1 halves, add the extra half means I've got 3 halves. Okay. Once we have them as top-heavy fractions, it is far easier to then consider that we will be working on a single common denominator. So 9 and 2, that would be 18. Double to double my 32, giving me 64. 2 has been multiplied by 9 to get 18, so I need to do the same to the 3. Well, as before, we said that 9 3s are 27. At this stage, we can then look at just subtracting our numerators. 64 subtract 27, that will leave me with 37. Okay, so we've got 37 over 18. Now, you may be form or you may be asked to give it as a mixed number. It could tell you in the question. 18s go into 37 twice. It goes. Okay, sorry about that interruption. It appears that we were knocked offline. Apologies, I don't know when we were knocked offline, but you can see my working out is there for the top question. I've currently just gone and found I've changed 3 1/4 to be 13 over 4. I'm about to multiply it by 2/3. I've got Mr. Sanders watching. Pardon? I've no idea. It was just automatically paused. Okay. Sorry about this. This is us learning how on earth YouTube Live happens. Right, okay, where was I? Right, so we are multiplying 13 over 4 by 2/3. We do not need to find a common denominator. It will just happen to come out. So we can just multiply our numerators together. So 13 multiplied by 2 gives us 26. And we can multiply our denominators together. 4 multiplied by 3 gives me 12. We would then look, 12 goes into 26 twice, leaving me with 2 left over. But I'm not going to leave it like that. I need to simplify it further to 2 and 1/6. I could have done it at this stage. I could instead have said, well, 26 and 12 are both even, so I could have gone to 13 over 6, and then that would have also gone to 2 and 1/6 at that stage. Okay, thank you there. That's those done, and I'm up with simultaneous equations. Fantastic, and this is the first time I'm seeing these questions. So if I go wrong, it's because I didn't practice them beforehand. It is live. Okay, right, what have we got here? We've got simultaneous equations. We've got a 4x plus y equals 25 and x minus 3y equals 16. I'm thinking I will change equation number 1, and what I'm going to do to that is I think I will multiply equation number 1 by 3, okay? Now, the reason I'm doing that is I can see y. I can see I've got a single y. I can imagine I've got 1 y there. If I multiply it by 3, I will get something conveniently to do with this minus 3. So I need to multiply all 3 parts of it. So 4x multiplied by 3 gives me 12x. Y multiplied by 3 gives me 3y. And 25 multiplied by 3 gives me 75. I can now look at these 2 equations. Okay, these 2 equations, if I was to add these 2 together, conveniently that minus 3y plus the 3y they will cancel out to 0 y's. So I'll have x plus 12x, leaving me with 13x. Wow, I'm going to get a tricky number here. And 16 plus 75 leaves me at 91. So once I've got a single letter on its own, then y will be that 91 divided by 13. You may want to write out your 13 times table if you're unsure, but thankfully, being a mathematician, I can work that one out to be 7. Once I've got my y, I cannot leave it just as finding one of my numbers. I need to find both of my numbers. So I now need to find x. The one I think I will go for, to keep everything positive, I will put it back into 1. So sub in 1. Okay, so there I got 4x plus what I now know to be 7 equals 25. I've now got a linear equation. So the inverse of adding 7 is to subtract 7. So I'll do the same on both sides. That will leave me with 4x on the left-hand side, and it will leave me with 18 on the left-hand side, and the lights have just gone out. Okay, now I've got 4x equaling 18. I can find a single x by dividing my 18 by 4, and I get 4.5. So I've got a value for x and a value for y. Okay, that was simultaneous equations. Mr. Sanders, hit me. Okay, I am sorry, year 11, I'm just being put off by a colleague who's supposed to be allowing me to focus. Right, the new question. The new question is, find the equation of the line with a gradient of 4 that passes through the coordinate of -1, -6. The key fact we need to know for this one is the standard equation for a straight line. The equation for a straight line will be y equals mx plus c. Key factors on this one is the m. We need to know that that is the gradient. And we are trying to find the c because we can use the y and the c because the y and the x, we've been given them here. I am stuttering due to that put off earlier. Right, I can now substitute in the numbers that I've been given. I know that this is my x coordinate, this is my y coordinate. So if I replace those, I've got -6 equals, well, the gradient is here, 4, lots of a -1, plus c. So I can say -6 equals -4 plus c. Well, to go from -4 to the -6, to keep them balanced, keep them equal, c must have been -2. So now that I've got that, I've got my c, my m is here and here. So I can replace those. I can say y equals, I'm just making sure I'm still on the screen, y equals 4x subtract 2. There we go with that one. I'll leave that on the screen while Mr. Sanders remembers he should be giving me my next question. Have you tweeted out a link to this video because it's separate to the last one? If you go on the YouTube on the page, share, and then paste it into the tweet deck, you'll be okay. Because it'll be a different hyperlink to the previous. Right, we are now solving an inequality. We are solving an inequality. We've got 2x plus 4 is less than 6. I'm going to treat this inequality as an equation to start with. So I'm going to write it almost identical and say 2x plus 4 equals 6. Similar to when we did the simultaneous equations, I'm going to subtract 4 from both sides. Once I do that, I will be left with 2x on the left-hand side. I'll be left with 2 on the right-hand side. If 2x equals 2, then x equals 1. And there, we have solved it. Thank you very much, Mr. Sanders. 28 viewers, beating you, Milner. Okay, we've got a slightly trickier inequality here where we've got what we class as the unknown on both sides. We've got 4 separate parts. I will start off identical to last time. 4x plus 3 equals 3x plus 7. This is all about keeping balance. Keep it balanced, do the same to both sides. Whatever you're doing to one, you must do to the other. I will start by, I'm going to subtract 3x first. If I subtract 3x, then I know I've got a nice convenient x all by itself, because x will disappear from here. I'll be left with x plus 3 equals 7. Well, I can see a number plus 3 gives me 7, so therefore x must have been 4. I must go back. I've just remembered the previous question, sir. Can you find it? I forgot on the previous one. I need to put that inequality symbol back in. I've not moved or divided by negative, so I can put x is greater than 4. And remembering on this one, I'll show you there and here, need to put that inequality symbol back in, otherwise I'm going to lose one of my marks. That was me getting distracted. So make sure you are focusing when you are in your exam tomorrow, no small distractions. Okay, we're continuing to solve inequalities. This time you will see I've got just one x appearing in the middle, but I've got numbers on either side. But I'm told that 2x, that's what 2x has to be between. I'm just wanting to know what x is. Well, to go from 2x down to x, I divide by 2. Okay, so I need to do the same across my inequality. So that leaves me with 7 is less than x, which is less than or equal to 10. When we see the word integers, integers are whole numbers, and we need to satisfy, as in what whole numbers are true that are greater than 7 but less than or equal to 10. So greater than 7 means I cannot use 7, but I can use 8, I can use 9, and I can use 10 because it allows it to be equal. Okay, there we go, Miss Sanders. When are you taking over? Okay. Miss Milner, any comments from students so far?
Always an equal sign, and I'm just putting, you do not need to use the equal sign, you can leave it as
Yes, very true. You don't need to replace it with that equal sign. I just do it out of habit. I prefer solving equations than inequalities. Right, Miss Sanders clearly is giving me the tricky ones that he doesn't want to solve himself. So, right, now I've got 32,000 centimetres squared is equal to some amount of metres squared. The glare is quite glary. Okay, fantastic. Do I need to move it this way?
Move it down a little bit.
Down a bit, left a bit, right a bit.
Just covering over like the question. There, that's good.
So if I keep it to this side.
Yeah.
Yep, fantastic, thank you. Right, the fact I must remember in this is when I'm converting centimetres squared into metres squared, it is not a case of just dividing by 100, because that is what it is to go from a centimetre, to go from metres to centimetres. If we considered a square that measured 1 metre by 1 metre, that will obviously be 1 metre squared. But an identical square would be 100 centimetres by 100 centimetres, and I'm going to run out of room inside that box. Well, 100 multiplied by 100 gives me 10,000 centimetres squared. So we can now say that, I'm going to change colour pen, 1 metre squared is equal to 10,000 centimetres squared. Well, I've got 32,000 centimetres squared here, so that must mean I've got 3.2 metres squared. There is absolutely no problem in the exam. You just join yourself some diagrams to help remember, label. You know that a metre is equal to 100 centimetres, so you can therefore find your conversion units. You don't need to memorise them. What are we up to next, sir?
You pick. Do you
I have no idea what we're doing. Pardon?
Functions, algebra, surds.
Give me a third, please. Simplifying a third. Okay, simplifying thirds, you need to be thinking about your square numbers when you are simplifying thirds. We've got 45. Hopefully, those of you that are watching are thinking 45. I know what square number goes into 45, and you are right, it is 9. 45. Personally, I prefer to write root 45 is equal to the root of 9 multiplied by 5. I then go, I'm going to show every step. I'm going to go, well, root of 9 multiplied by 5 is the same as root 9 multiplied by the root of 5. And I know what the square root of 9 is. I know that it's 3. So I can then put 3 root 5. It's a very similar method for any ones like this. If you can think of a square number going into it, we've got 125. You might think, I know that that is 5 cubed, but you're looking for square numbers when you are simplifying surds. So we have a root of 125. We can say, if we wanted, we could say that root 125 is equal to the root of 25 multiplied by 5, because you can work out the square root of 25. You cannot work out the square root of 5. Apologies for my extra flick on that 5. So we would have the root of 25 is 5. We don't know the root of 5, so we'll leave it as 5 root 5. Okay, am I continuing or are you wanting to take over? You are more than welcome to take the heat off me.
I've got someone saying, mate, can you teach me everything about graphs, please?
Everything about graphs.
We carry finish these surds off, we'll come back to those.
Okay. Which, are you going to rationalise it down?
This one first.
Okay.
Are we on the, can I have a pen?
You've got 2.
Thank you. Hello everyone. It's quite nerve-wracking this. So, I'm going to carry on after what Mr Russell just said there. I'm going to expand some brackets involving surds. Now this works exactly the same way as expanding brackets involving algebra, but obviously there are surds involved. So first thing I'm going to do 2 multiplied by 3, which is obviously 6. I then do 2 multiplied by negative root 2, which would be minus 2 root 2. And then I'm going to do root 2 times 3, which would be a positive 3 root 2. And I'm running out of space. And finally, I've got root 2 times negative root 2. So that would be negative root 4, which, as we know, can simplify it to just 2. So that would be minus 2. So far, we have expanded. We've got ourselves a mark. But in order to get full marks for this, we then need to simplify that as well. So we have 6 at the front, take away 2 at the end. 6 take away 2 is 4. Then we've got minus 2 root 2 plus 3 root 2, or let's make it a bit easier for ourselves, 3 take away 2 root 2, which would just be a positive root 2. That is as simple as it will go. Okay. One final thing from me about surds, it's disappeared. We are going to rationalise the denominator. Okay. All that means is we are going to get rid of every surd that's in the bottom of that fraction because they are nasty to work with. Okay, so in order to do that, we are going to need to multiply by something. So we're going to take whatever surd is on the bottom and we're going to multiply both the top and the bottom by that surd. Now what that will do then is if we did the bottom first, root 2 times root 2 is, as we know, root 4, which would then simplify to root 4 is just 2. And on top, we would have 3 times root 2, which is 3 root 2. So that would simplify to 3 root 2 over 2. Be very, very careful with this one. That's as far as this one goes. But sometimes that number there and that number there will simplify further, just like a normal fraction. So be very, very careful to make sure you've gone all the way through that. What's next, sir?
You've got a indices question.
Oh, brilliant. Thank you.
Fractional
Straight into it.
indices.
So, evaluate 32 to the power 2/5. Now, the word evaluate just means work out. Okay, so this is a fractional power. It comes up all the time on Higher. Okay, and it is important you know what to do. So what we're going to do is we're going to work from the bottom and work our way up from that. So whatever number is on the bottom is the root that we do. So 32 to the power 2/5 is going to be the same as the 5th root of 32. And whatever answer that is going to be to the power of 2. Okay, so write it out like that. You show the examiner you know what you are doing. How am I doing for glare so I can see a bit?
As long as you're that side, you're fine.
Okay, so at this point, I'm thinking, what is the 5th root of 32? So what multiplied by itself 5 times gives us 32? Now remember, this is a non-calculator exam. It's not going to be a nasty decimal. Work your way through. So start low. Well, it's not going to be 1 because 1 times 1 times 1 times 1 is 1. So let's try 2. So let's try 2 times 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that must be what it would be. So the 5th root of 32 is 2, and then we need to square that. So 2 squared is 4. Okay? Another example of the one underneath, just for a bit more practice, we have got, sorry, I haven't got a rubber. So 27 to the power 2 over 3. Once again, we're going to work our way upwards. So whatever's on the bottom is the root we're going to find. So we're going to find the cube root of 27. And whatever answer we get there, we're going to put it to the power of 2. So this time, once again, cube root of 27, it's going to be a nice number. It's not going to be 2 times 2 times 2 because that's going to be an even number. So let's try 3. 3 times 3 is 9, times by 3 again is 27. So the cube root of 27 is in fact 3. And we are going to square that, which gives us...
They can't see
9.
if it's below there, so
Thank you.
there you go.
There we go. Hope you could hear that well enough.
Thank you
Mis-
very much to Lauren Woodcock for mentioning that one to us.
Thank you, Lauren. It's completely Mr. Russell's fault.
And just to mention, Year 11, any more chat like that, and we will turn that chat off.
Thank you. So now then, we're going to find the nth term of this sequence. So like I do for every single nth term, I'm going to find the difference between each one. So I'm going to find the difference between 1 and 7 is 6, between 7 and 7 is 10, and between 17 and 31 is 14. Okay, now this tells me, because they're all different, that this is not a linear sequence, it is a quadratic one. So I need to now find the second difference. So between 6 and 10 is 4, and between 10 and 14 is 4. Now, because that second difference is the same, we know it's going to be quadratic. Now, the next step is the one that my students normally forget. We have to half that. So half of 4 is 2, so this will actually be part of the sequence 2n squared. Okay? I'm now going to write the sequence again underneath. So we've got 1, 7, 17, 31. And underneath that, I'm going to write down the 2n squared sequence. So that just means the square numbers multiplied by 2. So if I write down my square numbers to help me out, 1, 4, 9, 16, 25, those multiplied by 2, I've got 2, 8, 18, and 32. Now I see, well, that sequence is 2n squared. This was my original sequence. And I want to see, how do I get from 2n squared to my original sequence? I'm just going to take away 1. So this must be the sequence 2n squared take away 1. Sounds like it's Mr. Starkie's turn to.
Well, that'd be very convenient because we're about to get to functions. Mr. Starkie, you ready to step in and solve some functions? Mr. Starkie's just stepped into the room, Year 11, so he won't be aware of what's going on. This green line, sir, can you keep your writing to this side? Apparently there's a glare down the middle of the page.
Go on then.
Start you off with a question there. You've got 2 pens. They can hear everything. Don't worry, 11 is just taking his blazer off. It is a non-blazer day after all.
Okay, there we are. Right, having just arrived and got this one shoved in front of me. So, f of x, we've got some effects. The effect is 3x minus 1. So, I'm asked to put some operations on x. I'm multiplying it by 3, and then I'm subtracting 1. This bit of notation here is asking for the inverse function of x. So what we've got happening up here, the x is being times by 3, and then we are subtracting 1. We're going to reverse those operations. So we're going to add 1, and then we're going to divide by 3. So my inverse function of x is going to be x plus 1 divided by 3. Okay. Next. We've done that one. They're having too much fun here, trying to set me up.
They did it to me, sir, as well, don't worry.
Okay, so this time we've got 2 different functions going on. We've got a function f of x, which is the one that we've just done, times by 3, subtract 1. We've got another function, g of x, which is x squared. And at the bottom here, we're asked to do a composite function. We've got 2 things happening. The key thing here is that we're going to start with f first. So looking back to what my function of x asked me to do, it says we are multiplying by 3 and then we are subtracting 1. So we're going to do that first. So I've now got g of 3x minus 1. So having done the function x, the x has been replaced by fx, which is 3x minus 1. to do the function g, we now need to square whatever we've now got in my bracket. So I've now got 3x minus 1 squared. Oh, and this is where we've got different options. If it's me, you'll be foiling. We might have a bit of moon and stars going on. So I'm going to go foil just so I don't do it wrong. So 3x times 3x gives me 9x squared. The outside term gives me minus 3x. The inside term is minus 3x. And the last term, the negative times the negative, gives me a plus 1 at the end. Okay, don't forget to simplify the 4 terms. And the benefits of doing FOIL are that your 2 terms to simplify are in the middle there. So we've got 9x squared minus 6x plus 1. And that's our composite function.
One more on function set before you're changing topic.
Thank you. Okay, so this time we've got a function of x which is described as 25 plus 2x squared, and we're asked to find the value of minus 2, f function of minus 2. So we can see this time that the x in the bracket has been replaced by minus 2, so we've got a bit of substitution going on. So where x appears in my function, I'm going to replace it with minus 2. So f minus 2 equals 25 plus 2 times minus 2 squared. Okay, so looking at what we've got there, think about your order of operations. I've got minus 2 squared over here. Minus 2 squared is going to give me plus 4. I've got 2 times there. I've got 25 plus here. Okay, so I've now got 25 plus 8, which gives me a value of 33. Okay, I think we are moving on from functions.
We are, sir. You're on a
So we-
completing the square form. Ones here, don't worry. We are literally having to write questions and answer them.
Right, on the spot. So we've got a completing. I'm glad Mr. Russell told me we're completing the square, but I should have recognised that from this bit of notation in my question here. So x plus a squared plus b. We're going to write this expression here in this particular form. So a in this case, a is always b divided by 2. So that second term there is going to give me 5 inside my bracket. So I've now got x plus 5 squared. You can see I've sort of matched up this bit here. Now, if we were to expand x plus 5, multiplying it by itself, we'd get x squared. We'd also get the 10x, but we'd also get a plus 25 that is extra to those first 2 terms in my original expression. So we need to we need to subtract that 25 straight away so that this part of my answer matches the bit that I've got underlined at the top there. Notice that plus 30 we've not used as yet. Okay, so we bring that plus 30 down, and now I can go straight and write it in the form that I'm wanting. So I've got x plus 5 squared minus 25 plus 30 gives me 5, positive 5. Okay, and just check that it does match up with the format that I wanted my original answer in. Okay, completing the square.
Do you want to take a break, sir, while I step in for some?
Okay,
You can
lovely.
help Mr. Sanders find some questions.
Huh? If you complete this way, might do that one first.
Really? Okay.
Have you seen that one?
Just now. You've got the purple pen as well, sir. Thank you. How are we doing? 39 views, 27 minutes going. Right. Miss Milner's also written me a fresh question. Find the coordinates of the turning point, wow, of Y equals x squared plus 6x plus 12. Okay, so this question will certainly be towards the end of the paper. It is quite a high level skill. It is also included on the A level. Fantastic. So the reason it's appearing straight away now is because we do need to be able to complete the square. I'm going to see if I can go for the same structure that Mr Starkie did, just to make sure that we can follow the same skills. So if I'm completing the square on this one, I'm wanting to put an x inside a squared bracket, but I know that when I multiply the x by my constant here, I'm going to do the same with the constant and the x again. So I'm going to half that 6 will give me 3. Well, just making sure I'm following Mr Starkie's method. If I then subtract what happens when I square that 3, that will give me 9 because I wanted plus 12. Leave me with y equals x plus 3 squared plus 3. So that gets me partway there. I'm now looking for the turning point. Now the turning point, this is whereabouts, if this was a graph, it literally turns. We are calling a turning point and actually finding out its coordinates. Well, on this one, we're going to use these two numbers that on this example conveniently are both 3. That was just a rough sketch. I was just showing you that it does turn somewhere. The turning point on this one, it will be the, what word am I looking for? When it's the minus of a plus or a plus of a minus. What's the actual word for that? Modular? No. It's not the same sign as the one in the brackets. Yeah. Okay. So my turning point, the turning point on this one will be minus 3. So you can see that sketch was nowhere near where it actually was. Okay, next up, what have I got? Okay, Miss Milner's written me a question here. Oh, thank you. Some student asked for a reverse mean question, so Miss has kindly gone out and found one for us. Make a gap in the middle. Is that better? Is that no glare? I know you've got a bit of a lag. Is that better? There we go. Right, reverse mean. 10 boys and 20 girls in a class. The class mean is 60. The girls mean is 56. Work out the mean mark for the boys. Okay, quite a lot of information here. First thing I'm noticing is that I've got 10 boys and 20 girls. Therefore, my class total is therefore 30. Well, as the class mean is 60, that means if I can work out the total that those students scored, I will do that by doing 30 multiplied by 60. Well, 3 6s are 18, but it wasn't 3 6s, it was 30 times 60, so that would be 1,800. Next up, I'm told I will switch colour pens to make it a little bit easier. Now, when I do like a bit of colour, I know that you lot that watch the science one, you like a bit of colour. So we've got 20 girls, their mean is 56, so I'll take the 20, I'll multiply it by 56, giving me, well, 20 times 50 would be 100, but I've got 6, so that's one, I've got a complete mind block, 1, 1, 2, 0. Okay, so when I know the girls and I know the class total, it's just a case of subtracting. I have 1,800 for the full class. 20 of the girls are scoring 1,120 between them. So if I do the subtraction, well, I'm going to get a 0 here. I will borrow. I have no idea what's going on around me. Sorry, year 11. So 10 subtract 2 gives me 8. I now got 7 subtract 1 give me 6. And the ones go. So the boys total was 680. Convenient, if I look back over here, I've got 10 boys. So the mean mark for the boys, which is what I was being asked about, it'd be 680 divided by the 10 boys that I've got, leaving me with 68. One thing that I'll generally check on that is 68 a sensible answer? Well, I've got 68 for the boys, there were less boys, 56 for the girls, there were more, and 60, thankfully, is between those two, so it is a sensible answer. Okay, let's see what they're going to sting me with next. To the person who constantly asks on our feed to be shown graphs. We cannot possibly show you everything there is to do with graphs, but we can show you some basic features of graphs. We've got 3 that we have been asked for here. We have y equals x squared. An axis is always useful, so I will need a y and I will need an x. The y equals x squared is very symmetrical. It's reflected in the y-axis. That is your graph of y equals x. If they were to ask you, if they said y equals x squared maybe plus 4, well, 4 is a constant, so that just means it moves up 4 as such, okay? Y equals x cubed. Now that one, it's got a little bit more to it. Miss Sanders, be prepared, you'll be stepping up shortly, because I need a breather. Y equals x cubed. The general pattern is something like that. It's going to go through our origin. It will go above and it will come back below. Yep. So there we go. Again, if it's got anything added on, it will just be lifted up. The next one, we've got y equals 1 over x. So again, we start with an axis, and the basic pattern of that, it needs to look just like this. Okay, so we've got sloping down from the top right segment and into the bottom left segment. There we go. Okay, what have we got next, guys?
Direct proportion.
Direct proportion, thank you very much. Okay, we've got R is directly proportional to S when R is 36, S is 9. Find S when R is 40. Am I making sure it's all on the screen? Yeah, fantastic. Okay, so if it's directly proportional, that is a big hint. We will go R is directly proportional to S. That's the first part where we need to find the equation, and then we'll be substituting in the numbers that we've been given. Well, R, we know, it tells us it is 36. We're wanting to find K, the constant of proportionality. We must find that. We are told that S is worth 9. So 36 is K lots of 9. So what number am I multiplying 9 by to get me 36? Well, it is 4. Okay, so if I went back to this equation, I would rewrite this one as R equals 4S. I'm being asked to find S when R is 40. So if I substitute 40 in place of R, I know that my constant was 4 and I'm needing S. So 40 is 4 multiplied by 10. Therefore, S is 10. Okay, Sanders, are you ready?
1 second.
Okay. Dealing with a request, fantastic, good to hear. And how are we doing for viewers? 49 viewers, fantastic, thank you. Give us some more likes. We've only got 2 thumbs up, and one of those was me to test it was working. A quick one whilst they sort something out. Okay, make X the subject. Okay, when we are being asked to make X the subject, or any letter the subject, we want it to appear just once and on one side of the equation only. Okay, currently, the X that we are wanting appears twice, and annoyingly, it's on 2 different sides of the equation. I need to get it all onto one side to start with, so I'm going to keep the XY that's on the left, and to get the X that's currently on the right onto the left, I need to subtract it from the right. So I'll have XY minus X equals A. Okay, now I've got it all on one side. That allows me to do a beautiful skill in mathematics, factorising. Factorising allows me to just write it once. Well, X was multiplied by Y, and if you always remember, there's invisible ones where we don't have any numbers appearing, so I need to subtract what we have, a Y minus 1 in our brackets. We can then say that that is equal to A. If we were asked for A as a subject, that would have been fine. It would have been fine there, in fact. But we were asked for X to be the subject. So now that I've got X, I can work out how to make that the subject. I currently have X lots of that whole bracket equal to A. Well, the A there, I need to do the inverse operation of multiplying by this bracket, which would be dividing by the bracket. So I'm left with y minus 1. And why not stick it in brackets just to show that that's what you were dividing by. Okay, Mr Starkie, Mr Sanders, are we okay to move on?
We are.
We are, fantastic. I'll leave the pens there. Oh, we've got a personal request now.
Personal request, yeah.
Personal request.
Just me. Right, that is it about there?
Yes.
All right. Okay, but back to proportionality, and we've now got an inverse question. Special request from Lauren Woodcock. First shout out for Lauren. Okay, so D is inversely proportional. D is proportionality sign, inversely proportional. Inverse means 1 over, and we've got an R, inversely proportional to R. So usually quite typical, these questions. We're now given a pair of values that work, so we're told that D equals 125 when R equals 16. Well, just before we do that, we're going to replace the proportionality symbol with equals and K. And when it's inverse, the K stays at the top of your fraction. So we've got D equals K over R. Let's go back to my question. We know that D is 125 when R is 16. Okay, so at this point we can multiply both sides by 16 to figure out what K is, which I think, I'm just looking, is that 2,000, chaps? 16 times 125, is that 2,000?
258.
Yeah.
Yeah.
Okay, thank you very much. So we've now got that K equals 2,000. So back to my original equation here. I now know that D equals 2,000 divided by R. Right, go into my question, and again, quite typical. I'm given that D equals 40, and I'm asked to work out what R is. So I'm just going to substitute 40 for D. So we've now got 40 equals 2,000 divided by R. Okay, so a bit of manipulation required here. Multiply both sides by R and divide both sides by 40. So we're going to get 40R equals 2,000. Divide both sides by 40. We get R equals 50. Okay, and we've finished that inverse question. Thank you. Okay.
Request, sorry, it was a request.
Another request.
And this one goes out to, who wanted the alphabet crew? Where is it? Isabel Buckley. Thank you very much, Isabel.
Isabel Buckley. Okay, that's right. Good call, Isabel. So, prove the sum of 3 consecutive odd numbers is a multiple of 3. Okay, so firstly, we're going to define our odd number. Well, all even numbers can be represented by 2n. So if we say that even is 2n, then that means that odd, to get an odd number, I add 1 onto that. So my first odd number is 2n plus 1. And if I want 3 consecutive odd numbers, then my next odd number will be 2n plus 3. And the third consecutive odd number will be 2n plus 5. Okay, we're asked for, going back to the question, we're asked for the sum of, which means we're adding these together. And we're asked to show that it's a multiple of 3. So if we collect together that big mess that we've got there, we've got 2n, 4n, 6n. We've then got 1, 3, and 5, which makes 9. Okay, so we've collected it together. Our expression is 6n plus 9. And to show that that's a multiple of 3, we need to take out a factor of 3 and into a single bracket 2n plus 3. Okay, and at that point, you've showed to your examiner that anything multiplied by 3 must be a multiple of it. Okay,
Mr Sanders is up.
Mr Sanders is in.
And it's to Ben Peel.
Right.
And Mr Sanders is not Snadders, he is Sanders.
Got
So
the
be
question.
careful what you type in.
Sign cos turn. Can I have?
Do you want that?
Yeah, yeah.
Yes. Do you want the prompt?
Right. Yeah, yeah. Go on then. So,
Can't
So-
see that.
you do need to know the basics of how to sketch the graph, the sine, cos, and the tan graph. Okay, so the sine is the basic one. Okay, we need some axes. Now, trig graphs are a little bit different to normal graphs in the fact that the axes go like this, where we've got a 1 and a minus 1. Okay, so I've drawn my axes, and I'm going to switch colour. So the sine graph then is the one that starts from the middle, and it's going to do one whole wavelength from 0 to 360 degrees. So we'll have 180 degrees in the middle. For the sine graph, we start at 0, we go up till we get to 180. We go down. Starkie, you've ruined it now. Okay? So we go up and down through 180 and back up, back to 360. Mr. Starkie's brought his invisible unicycle today, apparently. Apologies, guys.
Was the word you were after?
Cycle. Okay, thank you. Okay, cos x is very similar. We're going to use the same scale. Sorry about this, Ben. I'll have a word with Starkie in the morning. 1 and minus 1 again. We're still going to go from 0 to 360, and it's still going to be in the same shape. But this time, instead of starting at 0, we're going to start at 1. Okay, so this time we're going to go up from 1, and we're going to go down through 90 degrees, back up through 180, and to the top up there. So it's exactly the same graph, it has just been shifted along by 90 degrees. And the last one then, the tan graph. So this is the most obscure one. Once again, we're going to go from 0 to 180, 360, and I'm going to put the middle ones in for this one as well, and 270. Now this is the one, it will cut through 0, it will cut through 180, and it will cut through 360. However, it will not touch anywhere at 90, so it will go up like this. Okay, now if you try to put shift tan of 90 into your calculators, you'll see it says math error. Okay, that's because at no point does it touch that 90 degrees, that 270, etc.
It's a very fancy word, sir.
It's a very fancy word. It's mine and Mr. Russell's favourite mathematical word. It is an asymptote.
It certainly is.
Don't ask me to spell it, please.
Nor me.
What's up?
Do you want to finish on the last two questions?
I'll do one.
Okay.
I feel like you should finish this off. You're the host. Right, okay, so just because we are non-calculated doesn't mean we can't be doing areas of circles. So we've got here, calculate the area of a semicircle with diameter of 28 centimetres. Leave your answer in terms of pi. So to help myself out here, I'm just going to draw a little sketch. So there is my semicircle. And for this, I need to remember how to find the area of a circle. So if Miss Bailey was here, she would sing. To find the area of a circle, it is pi times radius squared, pi r squared. Okay? So if our diameter is 28 centimetres, our radius will be 14 centimetres. So we're going to do pi times 14 squared. Now, you do need to know your square numbers up to 15 squared. So 14 squared is 196. So that would be pi times 196, or 196 pi. Don't just leave it there though. That would be if it was a whole circle. So we are going to half that. So we've got 196 pi divided by 2, which is, Mr. Russell?
196 divided by 2.
Yes.
98.
Well done, Mr. Russell. 98
Just checking
pi.
my work.
It is late, okay? And it is 98 pi, and that is our final answer.
Units?
Did you want? Of course you can, Milner. Come in. In you come. Miss Milner's going to make a guest appearance, guys. There we go. Nice try.
She's only doing it to prove that she can do higher.
I'm watching you. Right, just in case you get a question that says calculate the perimeter of a semicircle with diameter of 28. Okay, so if we're given the perimeter Okay, perimeter is the distance around the outside of the circle. Okay, but instead of being called circumference, it's called perimeter because it's got a straight edge there. Okay, so to find, because we're not finding area, finding the distance around the outside, okay, for the circumference, okay, you normally do pi multiplied by 28, okay, and in this case, it's going to be 28 pi, all right? Now, because that would give us the circumference of the full circle, if we only wanted half of the circle, what we'd need to do is divide that by 2, okay? And if we divide that by 2, that gives us 14 pi. However, for the perimeter, we also need this straight length as well. So we need to add on 28 centimetres. Okay, so just make sure you do that. All right, so that would be 14 pi plus 28 centimetres. Right, finally to Mr Russell, is this the last question?
It will be the last question due to it almost being our bedtime and the battery on the iPad about to go. Have you just picked up the 2 pens?
I've picked up all of them.
Fantastic, thank you. Okay, we are finishing with a simplify of some algebra. I'll try and move it so it is not in the glare. Okay. Time for bed after this, year 11. Okay, x squared plus 7x plus 12 over x squared minus 2x minus 15. So when we've been asked to simplify a fraction such as this, we are thinking it will more than likely factorise top and bottom to therefore allow us to cancel some brackets out. So I am looking. This skill will apply even if you don't have it as a fraction, you will still be able to do this skill. We're looking for numbers that multiply together to give us 12 and add together to give us 7. I'll give you 3 seconds to think it while I also think it out. Okay. So I'm going to replace that top line of working out. I'm going to put it into 2 brackets. I'll have an x in both. It's the only way I can get an x squared. As both are positive, it's giving me a hint that it can only be 2 plus signs in my brackets. And my numbers multiplying together, did you get it right? It was 3 and 4, because 3, 4 is 12. 3 plus 4 is 7. Fantastic, well done. Okay, the bottom line. It starts off similar. We do have the x squared, so I know straight away I can put x's in both brackets. We're wanting numbers that multiply to be a minus 15 and add to be a minus 2. 3 seconds again, while I also figure it out. Okay, I've got it. So this time I'm wanting to make sure I get a minus 2. Well, my numbers, hopefully you realise there were 3 and 5, because 3 5 gives you 15, and they've got a difference of 2. I need to make sure I have a minus 2. So minus 5 plus 3 would give me that negative 2 here. As you can see, I now have 2 brackets the same. So they will simplify, give me a final answer of x plus 4 over x minus 5. There you go. I've got 1 final sheet to give you. No, I've got 2 final sheets to give you. It seems that we've all 3 final sheets to give you. We've got good luck, year 11. A shout out to Ben Peel. Thank you very much, Ben, for all the comments and feedback you've been supporting the others with. And I'm sure there was 1 more. Where's it gone? Oh, it's a good luck. So it appears that we had 2 good luck year 11s. All the best. Sleep well, and we'll see you for Booster at 8:15 in the morning. Good night. 56 followers and 14 likes.
Oh my